I am Narayana, Chemistry Senior Faculty, IIT Narayana. Today we are going to discuss about the JEE Mains Paper 29th Shift 1. 51 question belongs to conductance problem. The conductance is, if you take this question, here you can answer this lambda versus root C. If you see that root C, the conductance will be decreased like this. Once conductance is decreasing means year to year conductance is increasing. As the concentration is increased, the conductance will be sharply decreased. That is why it will become first option will be the answer. 52. See the 52 question. 1,2 disubstituted benzenes which could able to form intramolecular hydrogen bonding. 1,2 disubstituted benzenes which could able to form intramolecular hydrogen bonding can be a steam volatile substance. That is why the options will be A and B. A and B means, yeah, that will be third is the question. Key is third one, right. Next, okay, 53 question. If you see that aryl halides containing electron withdrawing groups like nitro group with respect to halogen at para position or ortho position undergo nucleophilic substitution reaction through ARSN2 mechanism. Therefore, the option will be 4. 54th question, if you see that this is the theory based question, options, correct options will be CDE. So, your key will be 1. 55 question is also theory based question only. So, this theory based question, the radii of the isoelectronic species increases in the order. More the positive charge, lesser will be the size, more the negative charge, more will be the size. So, statement 1 is correct. The magnitude of the electron gain enthalpy of halogen decreases in the order, that is also right. That is why both the statements are correct. That is why your option will be 4. At the temperature, compound AB2 dissociate as AB2 and half B2 having degree of dissociation x. So, small compared to unity. In the question, as they mentioned, x is very small. So, wherever x comes in denominator, you can neglect that part. That is why most probably it will come, second option will be the answer. So, that is you can write AB2 gas gives AB gas plus half B2 gas. So, here if you write Kb, Kp is equal to dissociation constant at pressure, partial pressure is equal to partial pressure of AB gas into partial pressure of B2 gas by partial pressure of AB2 gas at equilibrium. If you write the partial pressures, what you are going to get is Kp, right, Xp into Xp by 2 whole square by P. So, overall if you calculate, you are going to get second option. So, that is why the key will be second option. Next, element E has the ionization enthalpy 374 kilojoules per mole. E reacts with an element A, B, C and B with electron gain enthalpy values. Here in this theoretical concept, what you need to understand is the difference between the ionization enthalpy and electron gain enthalpy increases. Okay. increases, automatically ionic character increases. Ionic character increases. Therefore, the option will be EB greater than, EA greater than, EC greater than ED. Next. So, nucleophiles, there are 5 nucleophiles are in the list: ammonia, PHS3, theoretical BTDs, you can count that, NH3, PHSS and dimethyl sulfide, all alkenes are nucleophiles and OH minus is nucleophile. Those are the nucleophiles. Next, the stability of the complex compound. So, you need to write this inner shell complex and outer shell complexes here. Since cyanide is strong field ligand, all are inner shell complexes only. All are inner shell complexes only. Inner shell complexes, you need to write the delta naught value for each complex. Delta naught value for each complex you can write. Once you write delta naught for each complex, what you are going to get is, for first complex 1.6 delta naught you are going to get, all minus exothermic process, 1.8 delta naught, minus 2.4 and minus 2 delta naught. If you see the values of those things, automatically the third option will be the correct one. Next, 60th question. So, this question you need to write QP. QP is equal to NCP delta T. NCP delta T. NCP delta T means you can write N is equal to 0.5 moles is given, 0.5 moles and 0.5 moles. Cp value, since argon is the monoatomic gas, that is why 5 by 2 or 8.3 into, you can write T final minus T 298. So, if you calculate QP is equal, QP already given, QP how much is given, 500 joules, equal 0.5 into 5 by 2 into 8.3 TF minus 298. So, if you calculate everything, T final, it comes around 346.2 Kelvin. That is T final. Now, delta H by delta U is equal to Cp by Cv is equal to 5 by 3. This is a conceptual, right, 5 by 3. So, if you substitute delta U is equal to, it becomes as 3 by 5 into 500. So, it will be 300 joules. 300 joules. So, the option will be first option 348 Kelvin and 300 joules. 61 question, since it is Clemmensen reducing agent, Clemmensen reducing agent reduces carbonyl groups to saturated compounds. So, saturated compound means that ketone and aldehyde both will be reduced to saturated sp3 carbons. So, the option will be first option. 62, this is de Broglie's wavelength. Here, as we know, 2 pi r is equal to n lambda. 2 pi r is equal to n lambda. They have given, in question they have given de Broglie's wavelength and second orbit, that is why this is the nth orbit, 2 pi 4 a naught, what they have given already, 4 a naught is equal to n lambda. So, you are going to get 8 pi A naught by n is equal to lambda. So, option will be 2. 63 question, it is purely biomolecules question and theoretical concept. The bonding amylose, cellulose, glycogen and amylopectin. Amylose means it will be C1C4 linkage will be there, that is present in plant, and cellulose also, cellulose, it will be cellulose also present in plant only, C1C4 linkages, and glycogen, it is present in animals, C1C4 linkage, C1C4 linkage. That is why overall option, if you see, fourth option will come, A4 and B1, C2 and D3. So, that is the theoretical concept, right. Next, 64 NCERT based question, it is melting points order. Already you can refer the NCERT textbook, you can follow that order. Here it will be first option, because rhenium. Generally among the D block elements, 6th period elements have more melting points, 6th group elements, 6th group and as well as 6th group element, 6th period element also has more melting point. That is why rhenium has more than that of the osmium. Ruthenium is greater than technetium and iron is greater than manganese, right. Next question, this is Van 't Hoff factor calculation, colligative properties. For calculation of colligative properties, we can see alpha is equal to I minus 1 by n minus 1. This is the formula to be used. Since already alpha is given, for both the alpha is given, you apply that, calculate. If you calculate the for AX2, that will be present, alpha is equal to I 0.3 is given, yeah, 30% of the question they have given. And next, I is equal to 3, I is becoming equal to 3, and for next question I is equal to 1. So, means AX2 compound completely dissociate, and whereas AY2 compound is completely unionized. So, it is a non-electrolyte. So, option will be 4, right. Next, this is a based on Nernst equation question. That Nernst equation you can take. Of course, generally what we write, E cell is equal to E naught cell minus 0.059 by n, we write n log product concentration by reactant concentration we take. But here they have given, they did not simplify this equation, do not get confused with that one. RT by NF is nothing but what I have written, RT by F, okay. So, that is why what they have given. So, according to that product, here products are Mg plus 2 ions, because magnesium is more reactive, that is why Mg plus 2 ions are product, Ag plus is the reactant, Ag plus is the reactant. So, according to given options, if you check what happened, this with minus Mg plus 2 should be more at the numerator and Ag plus square should be denominator. If the options, if you look into, that is not there, that is why with plus symbol you need to write. So, first option will be the correct answer. This is hybridization concept, inner shell complexes, outer shell complexes you need to check. Mn, Br minus is a weak field ligand, so it should be outer shell complex. Outer shell complex means it should be sp3 hybridization, so paramagnetic in nature. Mn there, here it will be plus 2 oxidation state. Plus 2 means 5 unpaired electrons will be there, that is why it is paramagnetic in nature. Fe, F6, again fluorine is a weak field ligand. So, iron is in plus 3 oxidation state. Plus 3 means again 5 unpaired electrons are there, outer shell complex only, but here it is coordination number 6, that is why the hybridization will be sp3d2. And cobalt oxalate, cobalt plus 3, except in two complexes, that is CO H2O taken 3 F6 and CO F6 minus 3. Except in these two complexes, generally all cobalt plus 3 complexes are inner shell complexes. And cobalt in plus 3 oxidation state, it has 6 electrons, all electrons get paired up, that is why diamagnetic. D2sp3 is the hybridization and diamagnetic. And nickel tetracarbonyl, nickel tetracarbonyl, nickel is in 0 oxidation state. So, in tetracarbonyl all electrons get paired up, that is why it is a 4 coordination number, sp3 hybridization and diamagnetic. So, overall if you see that, fourth option will be the correct option, A4 and B2, C1 and D3. 68 question, if you see that, we need to find out the order of the reaction. Yes, order of the reaction, first you write the rate expression, R is equal to K into, for slowest step you need to write. So, that is why A and B2 we write, B2. Since A is not the reactant given, it is one of the intermediate formed. So, you need to write first step equilibrium. If you write the first step equilibrium, K equilibrium is equal to A whole square by A2, A whole square by A2. So, that is A is equal, concentration of the A is equal to under root K equilibrium into A to the power of half. This equation, if you substitute in the rate expression again, what you are going to get is R is equal to K into under root K equilibrium and A2 to the power of half and B2 power of 1. So, order of the reaction is sum of the concentration powers, that is why 1 plus half, 3 by 2 you are going to get. So, 1.5 is the order, that is third option. This is SRP values, more the SRP values, stronger will be the oxidizing agent. Among the given, if you check, Pb plus 4 to Pb plus 2 has maximum SRP value. So, that will be the strongest oxidizing agent. 70th question, that is IUPAC nomenclature, well known concept it is, right. You can give. So, it will be A, it will be 2 and B, it will be 3. So, overall it will be first option it comes, all IUPAC nomenclature, right. 71. CrO3 excess, CrO3, in fact CrO3 acetone is mild oxidizing agent, CrO3 excess is behaving like a strong oxidizing agent, but at room temperature secondary alcohols get oxidized to ketones and primary alcohols get oxidized to carboxylic acid. That is why when you treat this molecule with excess of CrO3, it is becoming into COOH. This is P compound, COOH, P. But when next step is P is reacting with ethylene glycol. Ethylene glycol is used to block the keto group. So, that will be blocked like this. That is COOH. Next reaction, Grignard reagent CS3MgI, methyl magnesium iodide. Since molecule contain acidic hydrogen, that will react with acidic hydrogens and you are going to get R compound is followed by hydrolysis is given. There is no change in the structure. Since methyl magnesium iodide replace this acidic hydrogen, so that's why, and followed by again hydrolysis, you are going to get the same molecule. So, actually Q and R remain same. Q is equal to R, remain same, and R now sodium borohydride. Sodium borohydride selectively reduces carbonyl group rather than COOH. It won't reduce the COOH group. So, S will be compound is this. That is the compound. Now, 0.1 mole, 0.1 mole, if you calculate the molecular weight of this compound, into 0.1, you are going to get the answer, that is 13 grams molecular weight, 130 you will get it, 130 into 0.1, 13 grams is the answer, 13 grams, right. Next, 72, you just count the number of sigma and pi bonds, right. Once you count, simply hexane, you write 6 carbons, and 1,3-diene. So, here it is 1,3-diene and 5-ine. So, this is the compound. Now, you count the number of sigma and pi bonds, you will get the correct answer 15, you are going to get the answer, right. This is preparation of potassium dichromate question actually. Of course, first step of the step, when iron chromate is treated with sodium carbonate in presence of oxygen, you will get Fe2O3, this is precipitate, Fe2O3 plus Na2CrO4 plus CO2 gas. These are the products. This is given in NCERT textbook directly. So, since they are asking about the in presence of O2 dash grams of here insoluble, this is the insoluble precipitate in this compound. That is why Fe2O3 weight is Fe2O3. They are asking about the molar mass of the compound. Molar mass means here it will be 160 grams, because iron is 56 into 2 and oxygen is 16 into 3, 48 grams. Overall, you are going to get 160 grams. Here in this, if A2B is 30% ionized, next question, then the value of Van 't Hoff factor is, 30% ionized. 30% ionized means simply, already we discussed about this second concept based on this same question. Here alpha is equal to I minus 1 by n minus 1. You apply that principle, you are going to get 1.6 is the Van 't Hoff factor. 1.6 means, since they are giving in the exponential factor, 16 is the answer. Next, among these given options 75, most basic, remaining all are aromatic amines, but only second one is aliphatic amine. Aliphatic amines are more basic than aromatic amines. Since aliphatic amines are more basic, that will react with HCl. The question is that only, each of them treated with HCl, the most basic compound will consume how many milligrams? 1 gram of that compound. 1 gram of that compound, if you take benzyl amine molecular weight, if you calculate benzyl amine molecular weight 77 plus 14 plus 16, overall 107 grams you are going to get, 107 grams. So, 107, if you calculate the number of moles of 107 means 1 gram by 107 number of moles of compound, number of moles, you are going to get 0.00934, 934. Mass of the compound is number of mass of the HCl, mass of HCl consumed is equal, because 1 mole of benzylamine react with 1 mole of HCl. So, number of moles of benzylamine is equal to number of moles of HCl. That is why 0.00934 into 36.5 grams, 36.5 grams. So, you are going to get 0.341 grams, that is equal to 341 milligrams, 341 milligrams. That is all. Thank you very much.